Welcome everybody. Here I am giving you presentation on Internet of Things. I am Eknath Kulkarni, working as assistant professor in Walchand College of Engineering. The name itself briefing about Internet of Things. We are putting everything on the net. Everything means every information related to us. Gmail is nothing but one type of information you are storing on the net, that is Internet of Things. If I want to store any sensor information, sensing information, location information, longitude and latitude type of information, I am storing it on the net, that is called as Internet of Things. We are storing everything on the net, that is called as Internet of Things. In this presentation I am going to cover introduction, technologies of IoT, embedded system and prototyping. First we will go for introduction. As I told you that Internet of Things is mostly related to you are putting the things information on the web. Just this is the small information. If you think that the internet has changed your life, think again, the IoT is about to change it all over again. Means every information which you are storing on the net, that information you are fetching for your purpose, that is called as use of Internet of Things, IoT. If I will brief you by taking a single example. If I stored information of longitude and latitude of my location continuously, means I am storing the information related to my position continuously on the web. So if anybody wants to meet me, he will directly able to meet me by looking at longitude and latitude, where am I. We will consider this application for a pizza delivery boy. If vendor want to know how many workers are working correctly and how they are utilizing their time, if he want to know, he will give the app to each and every worker, and that app continuously storing the location of them onto the web, that is called as Internet of Things. And vendor is able to analyze that information, that where the worker is now and what he is doing. Okay, this is called as Internet of Things. Our Prime Minister Narendra Modi has given a hand for doing this kind of activity. They come up with zero defect and zero effect policy. What is the meaning of zero defect? Means if I manufacture a power product, while going for manufacturing there are different kinds of multiple process will be there, so that does not affect to our environment. This is called as zero defect and zero effect. Actually this is called as zero effect, and zero defect means what product I manufacture that does not have any kind of defect, that goes through different kinds of robust testing, that is called as zero defect. This is a small definition. The Internet of Things is the network of physical objects related to physical information like buildings, square footage, devices are nothing but cameras, some sensors, vehicles, motion objects, buildings and other items which are embedded with electronics. Embedded with electronics means you are connecting this through controller, that is sensors. Sensors are going to communicate to controller, and that controller requires some softwares, that type of connectivity which enables these objects to collect and exchange data. Means if some accident happens, the information of that accident is directly carried out, which type of accident it is, how much severe it is carried out by the camera which is mounted on the local sites of the network, like your signals, they are mounted on the signals. If some accident happens, they will directly analyze that accident, how much severe it is, and they will directly computed internally search about the things related to which hospital is nearest, and they will directly send a message to them that accident happened, this type of severe accident will be there, this type of arrangement must require. These things are carried out with the help of Internet of Things. Okay. Procedure for doing any IoT application, you have to follow some procedure. Procedure means, if I want to do application, as I told about information system, that it is informing continuously my location. For that I have to first decide which task I have to carry out. Okay, for information storage I require to divide the task: client side application, server side application, which signals sensors will required, mobile is required, what type of mobile is required. Actually Android application, Android mobile is okay for this type, carrying this application. Then signal conditioning, if some signal conditioning comes when you want to connect with the sensors or some information transmission, if you want to transform some information into another format, that time you will require signal conditioning types of circuit. Connecting to the network, when you are sending that data, you must require a network. How you are sending data, what type of data packets are there, how you are going to receive, you have to think of these things while doing these kind of projects. Okay, then lastly analysis. What I told, that vendor wants to know where the workers are and what type of activity they are carrying out. This type of activity, this type of work is we are able to do it with analysis, because we have information of longitude and latitude. By the using that information, we are able to know where he is now. Okay, and what he is doing, means if he is in market, so he is doing some, means he is purchasing something from the market, we will able to conclude it. Okay, this type of analysis is carried out. Okay, just then what is web 2.0, web 3.0? Here comes the web 3.0. What is the meaning of web 3.0? First, before going for web 3.0, first we will see what is web. Web is nothing but a network, what we call it as WWW, World Wide Web. Okay, web 1.0, this is the in 19th century we are transforming the information in the form of text, that is called as textual interaction. Okay, that is one-way interaction. At that time we will call that web network is called as web 1.0. Now we are using web 2.0, dual type of interaction. You are able to send the images, you are able to view the videos, you are able to send the videos. Dual type of communication, like Facebook is the best example of web 2.0. And web 3.0, this is not different kind of thing, just we are embedding some analysis in web 3.0. What type of analysis is it? I will tell you the example. Okay, if I want to capture photos of Taj Mahal or any building, okay, if my what I have to do, I will directly go to the app, I will click on the app will be started, photo capturing app, okay, camera app, and that app analyze the image itself internally. So there will be some image processing algorithms will be there, that algorithms analyze the information, which image is it, If it is image of Taj Mahal, it will give you the whole information about the Taj Mahal. If you are capturing a particular part, the whole information is given you, that this part is developed at this time and who is developer of that part. This whole information is given. That is called as Web 3.0. You are using Web 2.0, and in that you are using some analysis algorithms. That is called as Web 3.0, right? Okay, this is the small video which is available on the net, on the YouTube also. I will play this video first of all.
Do you think an orchid will ever be able to tell its story? Do you think a flower will one day tell us where it was grown, how it was treated, or how it got here? Do you think it's possible to teach traffic to speak? Do you think a car can call an ambulance faster than a phone? Do you think it's possible for devices to automatically deliver important, often life-saving data to those in charge? Can you imagine an ambulance that gathers critical information before arriving at the hospital? And that a patient could be examined before he even enters the emergency room, saving precious time for the patient and his family. None of this is science fiction. It's all part of a concept that our team has been working on for several years, the Internet of Things. The main challenge for making this dream come true is finding a way to connect many different applications and technologies in one coherent network.
I think it will. The thing is, they are not connected.
For instance, there are 6 different systems at work in our medical example. We call them silo applications. Before the devices can talk to each other, we need to provide them with a common language. In other words, a set of design rules, protocols, and interoperable technologies. That's exactly what IOTA does. It installs a sort of grammar.
Connected to be combined as one.
IOTA's first task is to identify the basic components of each application silo. Next, all those components must be broken down into smaller elements. IOTA now arranges those elements into a more general framework.
First you are identifying the video, and then you are identifying your task, and then you are dividing that task, and after division you are going for some type of controlling part and how communication part, and then it is going for a analysis part. Okay, this is the second video which I am going to show you how in IoT works and how internal cluster will be there. Just go through the video, you will get some idea. Okay, I will start this video.
By now, you may have heard the term Internet of Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the internet, integrating greater compute capabilities and using data analytics to extract meaningful information. Billions of devices will be connected to the internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption. Here's an example of the big picture. Imagine an intelligent device such as a smart traffic camera. The camera can monitor the road for congestion, accidents, and weather conditions, and communicate that status to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Now, imagine that intelligent traffic system connected to other citywide transportation systems, which get data from their own intelligent devices, creating an ever larger intelligent system of systems. The really big possibilities come from analyzing the end-to-end data across that system of systems. For example, let's say the city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze the accident's impact on other city systems. Recognizing the accident is near the airport and 2 city schools, it could notify those systems so they can adjust flight and school schedules. It can also analyze and derive optimal routes around the accident and send those instructions to the city's digital signage system to guide drivers around the accident. And that's just one example of the potential benefits that can happen when intelligent devices share insight with other systems, forming ever-expanding systems of systems. But how do we get there? Regardless of the solution, Intel processors are designed to help you get to market faster and easier.
Okay, we will stop this video here only. I have taken this video from YouTube only. Okay, these are not my videos, but I am giving the lecture by using that videos. Okay, then why cloud? Actually, you heard this thing cloud in the video. What is the cloud and why we require the cloud? Cloud is nothing but you are providing some real-time analyzer or a real-time analyzer, real-time storage, so that you are able to do the things. Tracking and learning minimization. This is the best thing about the cloud. Companies directly give you a cloud, okay, and they are also providing some type of analyzer algorithm behind your code. What type of analyzer algorithm? If I am the new worker, I joined there, they will directly give me that cloud, okay, and I will work on that cloud. I will do some my activities, some programs through my logic building, through my steps, because everybody has his own logic and that logic might be unique and their steps might be unique. Nobody is able to analyze it. If I leave the company and new guy comes on my place, if he want to know what I have done, so that tracking and learning analyzer gives him training that how I solve the problem, what type of logic I used and what type of steps I used. Okay, this type of thing company is able to carry out. So this is the best thing about the cloud, why we are using the cloud. Okay, second thing, data analysis is easy. Take an example, okay, of company. If they want to analyze the whole data, the data is directly available on the cluster and on the shared memory, so anybody is able to analyze it. Means different softwares are able to analyze that data which is present in the shared memory. Monitoring and sophistication, this is where your biomedical applications come into picture. Monitoring sophistication, if I want to monitor what is going on, okay, because doctors from this country are not that much expert than the different kinds of different countries doctor. Like if US doctor is has an experience of heart surgery, and our doctor doesn't have that kind of experience, but he want to use his experience, so he will able to share that data remotely by using real-time systems. This is carried out with the help of cloud. This is the thing where we are using the cloud. Okay, 24 hours of production. If I am carrying out my product manufacturing through robots, it's 24 hours of production. So for that I require some dedicated system, so that I will able to observe it remotely. For that we are using the cloud. These are the examples. Okay, here comes the big one, Industrial Standard 4.0. What is Industrial Standard 4.0? Actually, Industrial Standard 4.0 is what our Prime Minister policy is there. Both are mostly common, same, zero effect and zero defect policy. Okay, most of the world is going for a digitalization, digital world. Everything wants the transparency of product. If I am taking the product, okay, I want to know what type of parts they are embedded in that product. If we will take an example of car, what do you think about how much time it requires to manufacture a single car? Just think on it. 4 to 5 seconds required for manufacturing a single car. This is a huge task, and 4 to 5 seconds is very minimum time required for manufacturing. So if I am the customer, I want different kind of color, different kinds of embedded systems, like I want airbag system only. I don't want to go for some stuff that is not useful for me. Why should I pay for that? I want my product accurate and precise. So company wants to deliver that kind of product, so they are going for Industrial Standard 4.0. The whole task is carried out with the help of robotics. The power of robotics, they want to use it for their production, and accuracy, precision is carried out through Industrial Standard 4.0. Each information, if they want to analyze what type of production they are carrying out and how that production is carrying out, means what type of information and how these products are carried out, how much time they spent in manufacturing whole the activity, like coloring, how much time we will require for coloring, how much time we will require for doing any kind of things. They want to know, they will able to know, they will able to analyze it. Okay, fast production, when you are using robotics, there is fast production. Transparency, every customer wants a transparent product, how it is manufactured and why you are giving me this kind of warranty. If I told you that my product has, I am giving you 1 year of warranty, he must have to assure about it, that the vendor is giving me 1 year warranty on basis of what and why. After 1 year, what shall I do? They want to know, because they want to purchase the product. So for if you want to remain in the competition, you will go for that. This is the small video of robotics. This all videos are available on the net, on the YouTube. Just I am taking for your understanding purpose.
New technologies are changing the world. They're also making the cars manufactured by the Volkswagen Group more efficient, safer, and more customer-friendly. The nature of car manufacturing is also changing in a similar way. In fact, the next batch of innovations is so extraordinary that experts are already declaring the dawn of a new industrial era, Industry 4.0. So what does manufacturing look like today? Traditional car production involving hundreds of identical vehicles lined up in a row no longer exists. The options available to customers are now so vast that each car becomes a unique and individual object. Cars are now manufactured to order. Data makes its way from the customer's order to the Volkswagen Group's systems and then to each individual section of production. A car consists of many thousands of individual parts. The press shop processes blanks for the bodywork. In the body shop, the car is baptized. In other words, it's given an RFID tag that can track it via radio frequency. This establishes which car body belongs to which customer order. The paint shop also receives information from the system world. In sequencing storage, the cars are placed in an optimal order for assembly. From here, information is transmitted to suppliers and pre-assembly as to which part is required when and where. In final assembly, the finished car emerges. The Volkswagen Group manufactures its cars using state-of-the-art technology, but development and innovation never stop. What does the future hold in store? Today, everybody is talking about Industry 4.0. It is a term used to describe a variety of innovative production processes. But what exactly does it mean? The Volkswagen Group has been shaping the future with groundbreaking projects for many years. Here are some recent examples. Digitalization. The digitalization of all elements of production is essential for a new era in industrialization. Everything is given a virtual likeness in the system world. The result is an Internet of Things. Example, 3D printing. Pressing tools are no longer shaped in a laborious manner. Instead, these tools can be made from steel granulate in a 3D printer. It's a technology that opens the door on completely new possibilities for design, with a level of precision unknown until today. Example, human-robot cooperation. In the past, protective grids separated robot arms and employees. In the future, employees and robots will work increasingly hand in hand. This is made possible by new security sensors. Robots take on especially monotonous and arduous activities. Today, robots already play a part in contributing to ergonomic workplaces at the Volkswagen factories in Chemnitz and Salzgitter. Example, big data monitor in logistics. The Big Data Monitor enables for the rapid visual processing of data from the 1,200 suppliers of the Audi factory in Neckarsulm. Where are the potential bottlenecks? Where is the greatest need for action? This data is now easily accessible at all times. The intelligent factory of tomorrow paves the way for efficient and cost-effective production unlike ever before. Industry 4.0 also means brand new opportunities for employees. The Volkswagen Group has already begun actively preparing its workforce for the future. The world is changing, not only in the automotive industry. Everything is in motion, and the Volkswagen Group provides the technology that moves the world.
Okay, here comes robotics and IoT. Robotics is a part of automation. When we want to do any kind of automation, we require robotics. Okay, because you have to use some machine when you go for 24 hours production. And machine learning means you are training some machine to operate some product. That is called as machine learning. And when you are using these things, this is called as when you are using robotics and machine learning things, you have to more focus on accuracy and precision. Accuracy is nothing but how much your product is accurate, and precision is how many times your product shows accuracy, precise readings. Okay. When there are some hazardous tasks, you are able to carry out these hazardous tasks with the help of robots only. Because hazardous means if you want to put some object, take out some object from 400 to 500 degrees Celsius, that kind of from that kind of temperature, you want to take out that product, and you want to carry out this to the another process, you have to submit that product to the another process. Then this is the difficult task. You are not carry out through manual, because there might be some mistake, it will make some disaster to that human being. So for that kind of task, we must have to use a robotics. Okay. Next slide there will be some there is an example of how robotics is carried out, is used for killing the terrorist. This is the task where they US use some robotics, drone, we call it as a drone attack. Okay, they have used some image processing cameras, the like a thermal cameras. By using the thermal camera, they predicted that where is the person actually, and they bombarded the bombs on them. Okay, just see this video.
Got enemy fighters in sight. They're all armed, maneuvering on your position. We'll be setting up for an engagement.
I will mute this sound. Just see, this is the thermal camera, and whole image processing is carried out on drone itself. Some controllers they have used, that is real-time operating controllers, and decision algorithms will be there. They decide that whether to bombard a bomb or not. Okay, that decision is directly provided to the controller, and controller will bombard the bombs. This whole thing is carried out through image processing and navigations. They have bombarded the bombs by using some decision algorithms and image processings. Just see. Okay, we will go to the next slide. Okay, here comes the ending of the slide. Thank you for watching this video. And if you have any query related to Internet of Things, please write below in the video some information. If you want to ask any information related to IoT, just write on the comment. I will respond you as early as possible. Thank you for watching this video. Thank you.
You